Welcome to the channel NCERT Maths Tutor. If you like this video, please like and subscribe. Also click the bell icon to get regular notification. Miscellaneous exercise on Chapter 9, Sequences and Series, question number 22 and 23 solution. Question number 22, find the 20th term of the series 2 into 4 plus 4 into 6 plus 6 into 8 plus so on up to n terms. So now they have given this particular series. So the first step is here to find the 20th term, we will find the nth term. So to find the nth term, the formula is an is equal to a plus n minus 1 into d. Now see, in this particular series, in each term we have two values. Here we have the first part as 2, the second part as 4. Then again in the second term we have the first part as 4 and the second part as 6. In the third term we have the first part as 6 and the second part as 8. So now here to find the nth term, first here we will write all the first part values of all the terms together and then we will write the second part values of all the terms together. So the first part value is here 2. Then here we have 4, here we have 6. So now this forms a sequence. Next again here we will write the second part values of all the terms, that is 4, then 6 and then 8. So here we have two sequences. See, now in this case, if you observe this one, this is in the form of arithmetic progression. Here if you find the common difference, that is 4 minus 2, that is 2, 6 minus 4, that is 2. So you are getting the same common difference. Here in this case also, this is in the form of arithmetic progression, because here also if you find the common difference, that is 6 minus 4, that is equal to 2, 8 minus 6, that is equal to 2. Here also we are getting the same common difference. So now here by using the formula, that is nth term is equal to a plus, that is an is equal to a plus n minus 1 into d, we will solve this one. See here, if you consider this one, here the first term is 2 and the common difference is 2. So by using this formula, here write on this particular series, that is 2 plus n minus 1 into 2. Then for this here we have the first term as 4 and the common difference, that is 6 minus 4, that is equal to 2. So put here a is equal to 4 and d is equal to 2 value in this particular case. So that is 4 plus n minus 1 into 2. So now here if you multiply this with this, we get here 2 plus 2n minus 2 into 4 plus 2n minus 2. This becomes 2n minus 2 will get cancelled. So we have here 2n and here 4 minus 2, that is 2. So that is 2n plus 2. So now here we got the nth term as an is equal to 2n into 2n plus 2. Now in the question they have asked us to find out the 20th term. That means n is equal to 20 here. So put here n is equal to 20 in this particular equation. So we get here the 20th term as a20 is equal to 2 into 20 into 2 into 20 plus 2. 2 into 20 is 40 into 40 plus 2. That is 40 into 40 plus 40 into 2. 40 into 40 is 1600 plus 40 into 2 is 80. So we get here the 20th term as 1680. Question number 23. Find the sum of the first n terms of the series 3 plus 7 plus 13 plus 21 plus 31 plus so on up to. So here we need to find out the sum of the first n terms of this series. See, in this series, if you find the difference here 7 minus 3 or 13 minus 7, you're not going to get the same value here. 7 minus 3, that will give you the value 4. 13 minus 7 will give you the value 6. So, see, you can make out here 7 minus 3 means you are going to get the value 4. Then 13 minus 7, that will give you the value 6. 21 minus 13, that will give you the value 8. And 31 minus 21 will give you the value 10. So here we are not getting the common difference same. That means this particular series is not in the form of arithmetic progression. And even you can't find out here the common ratio like 7 by 3 or 13 by 7. In that case also we are not not getting the same value. So this particular series is not in the form of arithmetic progression, or it is not in the form of geometric progression. But in the question they have asked us to find out the sum of first n terms. So now here we are using the difference method. The difference method is that, see, even though this series is not in the form of arithmetic progression or geometric progression, but if you find the difference between the two continuous terms, then we get this value, that is 4, 6, 8, 10. And if you observe these difference values, that is 4, 6, 8, 10, then these values are in the form of arithmetic progression. See, 6 minus 4, that will give you 2. 8 minus 6, that will give you 2. And 10 minus 8 will give you 2. That means here, if you find the common difference of the values 4, 6, 8, 10, then here we are getting the same answer. That means this value is in the form of arithmetic progression. So in this series, the series is not in the form of arithmetic or geometric progression, but when we find the difference, then the difference values are in the arithmetic progression. So now here let us solve this one. See here, to solve this particular type of question, I'm using the difference method. The difference method means, see, they have given the series like this way. Sn is equal to 3 plus 7 plus 13 plus 21 plus 31. Let us say that the last term, the nth term, is some an. So now let us take this one as equation 1. Next here, we have to find out here the sum of the series, and here we know that the difference whatever we get, that is in the form of arithmetic progression. That means we need to get this value here. So to get this value, here what I am doing is, again I am writing the same thing, that is Sn, by leaving one term. Let us say that here we have some value, that is 0. I am adding here 0, so that the remaining value I am writing, that is 3 plus 7 plus 13 plus 21 plus 31. Then here before an we have an minus 1 plus an. So like this way I am writing. Now let us say take this one as equation 2. Now here we will use the difference method. That means I am subtracting the equation 2 from equation 1. See, when I subtract equation 2 from equation 1, I get here Sn minus Sn, that is 0. Then 3 minus 0, that is 3 only. Then 7 minus 3. See, we are subtracting the corresponding values, that is this value. That is the reason that here, instead of writing this 3 here, I have taken here 0. I have added here 0. Adding 0 does not make any difference here. So, here 13 minus 7, then here it is 21 minus 13. So then we have here 31 minus 2, then here an minus 1, and here we don't have the term, that means minus an. So after subtracting equation 2 from equation 1, we get the values like this way. Now see here we have 0, that is equal to 3, then 7 minus 3 is 4, then 13 minus 7, that is 6, 21 minus 13, that is 8, 31 minus 2, that is 10. Then here we have the last term as n minus 1 term. See, in this case we have n minus 1 term. That is because, see, I have not included in this particular series the value 3. The value 3 is taken out. Totally here we have n terms. We have taken it in the beginning stage that totally here we have n terms. But after finding the difference, whatever the value we got, see, that is from 3 to up to here we have n terms, but I have removed this 3. I have written this 3 separately, so I am counting from 4. That means 1 terms we have to remove. So totally the last term is here n minus 1 term. It is not n term. This you have to keep in your mind. That is n minus 1. Then minus an. Now this an you can take to the left hand side. So we have an is equal to 3 plus 4 plus 6 plus 8 plus 10. 4 plus 6 plus 8 plus 10, so on up to n minus 1 term. Now here this forms a series, and this is in the form of arithmetic progression. So you can find the sum of this series by using the formula Sn is equal to n divided by 2 into 2a plus n minus 1 into d. See where here a is equal to the first term, that we can take as 4. The common difference is 2 and n value is here n minus 1. Now here we have n minus 1 term, not n terms. Because in this series, while finding the sum, we are not including the 3. We have taken this 3 out, just we have considered these elements. So from n, if you take one element out, so remaining elements are n minus 1. So that's the reason that here I have taken n is equal to n minus 1. So now apply these values in this formula. So we have here an 3 plus this 3 already we have here 3 plus, then apply the sum formula to this one, that is n is n minus 1 divided by 2 into a, that is 2 into 4 plus n minus 1. See, in the place of n we have to write what? N, in the place of n we have to write n minus 1. Then we have one more minus. That means this becomes n minus 2. So n minus 2 into d. d is 2. So we have here 3 plus n minus 1 divided by 2. 2 into 4, that is 8, plus 2n. 2 into 2, that is 4, minus 4. So we have here 3 plus n minus 1 divided by 2. 2n plus 4. So here from this we can take 2 value out. So 3 plus n minus 1 divided by 2 into 2, that is n plus 2. This 2 and 2 will get cancelled. So we have 3 plus n minus 1 into n plus 2. Multiply this with this. So we have 3 plus n square plus 2n minus n minus 2. So we have the final value, that is the nth term, as an is equal to n square plus n plus 1. See, now here we got the nth term. Next step is we need to find out the sum of the series. Now let us write down this value in the form of k, that is ak is equal to k square plus k plus 1. Next, let us find out the sum of this one, that is Sn is equal to sigma k is equal to 1 to n ak. Here we know the value of ak, just put that value in this place. So sigma k is equal to 1 to n k square plus k plus 1. So now here to solve this one, we are going to use these formulas, that is sigma n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Another formula is sigma n is equal to n into n plus 1 divided by 2. This is nothing but the sum of the natural numbers, and this is nothing but the sum of the square of the natural numbers. So now here let us apply the sigma values to all of these terms. So sigma k is equal to 1 to n k square plus sigma k is equal to 1 to n k plus sigma k is equal to 1 to n 1. We know the value of k square, sigma k square or sigma n square is this one. So just put that value, n into n plus 1 into 2n plus 1 divided by 6 plus sigma k value, that is nothing but n into n plus 1 divided by 2, then plus sigma k is equal to 1 to n 1, that is 1 n times, that means that is nothing but n only. Then from these three values here you can take the common term n out. If I take the common term n out, then we have here remaining value n plus 1 into 2n plus 1. So this you multiply with this one. So we get here n into 2n, that is 2n square, n into 1, that is n, 1 into 2n plus 2n, then 1 into 1, that is 1. Then plus n is taken out. So we have here n plus 1 divided by 2. Then here we have plus 1 because n is taken out. Next we have here n into 2n square, n plus 2n, that is 3n plus 1 divided by 6 plus n plus 1 divided by 2 plus 1. Next here you can take the LCM, that is 6 and 2 we have, LCM is 6. So if you're taking the LCM, here we get n into 2n square plus 3n plus 1. See, 2 3s are 6, that means you have to multiply this value by 3. So 3 into n plus 1. Then here we have 1. So here the denominator value is 1. So that is you have to multiply this value with 6. So plus 6. So we have here n into 2n square plus 3n plus 1. That is 3n plus 3 plus 6 divided by 6. That is n into 2n square plus 6n. 6 plus 3 plus 1, that is 10 plus 10 divided by 6. That is equal to, see, from this we can take the value 2 out. So n into 2 into n square plus 3n plus 5 divided by 6. So 2 1s are, then 2 3s are. So we have the final answer, the sum of the series, as Sn is equal to n into n square plus 3n plus 5 divided by 3. Thanks for watching.